Hello, my name is Chang Eun Kim, and I'm working at University of Bath, and I'm working with Professor Jan Hofmann for Filton demo case in NextGen project. Filton Airfield is a former airfield, and it has been recognized as one of the most important brownfield development opportunities in the UK. So in the NextGen project, innovative and sustainable development approaches will be investigated to recover water, energy, and materials in this area. And so this site, this filtering case will be a water circularity showcase for NextGen project. So this case covers, the filtering case covers water, energy, and material recovery. And the water solution is to demonstrate urban water reuse scenarios. And energy solution is to evaluate heat recovery from the sewer system and local use for heating. And finally, we are exploring possible circular circular economy solutions for materials recovery. So, so this slide shows the position of Filton case within the circular economy. So rainwater reuse, low-grade heat recovery, and materials recovery. So this is the new NextGen solutions for Filton case. So Filton ecosystem includes water, which is local use of rainwater from rainwater harvesting, and energy recovery means low-grade heat recovery from the soil system, and also we are considering biogas reuse for heating. And for the materials recovery, we are considering several options. For example, resource nutrient recovery from wastewater, and also we are considering some food waste reuse for as a fertilizer for agriculture application. So we evaluated low rainwater quality collected from direct precipitation. So as you can see, this table, the current values indicate the low rainwater quality, and the expected values here show the irrigation water quality standards. So this result indicates that rainwater collected in Filton is clean enough for direct use for other non-potable purposes like toilet flushing and irrigation. Within the next project, we have been collecting real rainfall data, and this will be used to analyze rainwater quantity and rainfall patterns in Filton. And these figures show the rainfall data collected from 4 weather stations, including our University of Bath weather station. And based on this result, weather station 1 and 2 show similar rainfall patterns with our University of Bath weather station, Filton weather pattern. So we use the historical rainfall data collected from weather station 1 and 2 for feasibility study of the rainwater reuse within the Filton area. So this table shows assumptions we used for rainwater harvesting feasibility study, and the aim of this study was to identify an optimum storage tank for rainwater harvesting. from YTL Arena rooftop. So the rooftop surface area is around 30,000 square meter. So for water reuse scenario, we consider the single use toilet flushing and irrigation and the combined use with different ratios. So we used water saving efficiency and cost savings as the performance indicators, and then we determined an optimal storage tank for this rainwater harvesting system. So this slide shows the water saving efficiency analysis result, toilet flushing, irrigation, and combined use. So as you can see, the water saving efficiency of the rainwater harvesting system is highly influenced by water demand scenarios. And from the result, except irrigation, toilet flushing and combined use for toilet flushing and irrigation, a storage capacity of the 400 and 1000 cubic meter would be enough for the applications considered in this study. So this table shows the detailed information we used to conduct economic analysis of the rainwater harvesting system. So we have incorporated UK-based water and energy cost for this analysis, and others obtained from previous UK-based studies on rainwater harvesting economic analysis. So here, this is the result of cost savings calculation. Cost savings were determined by the difference between mains only supply system cost and rainwater and mains water supply system cost. So positive cost saving values here means that the rainwater harvesting system is economically feasible for the given for the given conditions. So we have found that better economics are expected with tank size between 100 and 600 cubic meter for only toilet flushing and combined use scenarios. And this figure shows rainwater supply cost for different water use scenarios, and mains only supply cost. And you can see three sections in this figure. In A, the unit rainwater cost for all water use scenarios are equal to or lower than the mains water cost, which is 0.4 pound per cubic meter. Whereas in B, the unit rainwater cost for all water use scenarios are equal to or higher than the mains water cost. So when considering water saving efficiency and this cost analysis result, the optimum rainwater storage size is between 400 and 600 cubic meter, which is C in the figure. So all the results regarding this study will be published in Journal of Environmental Management very soon. So, further to the study on rainwater harvesting in YTL Arena, which is commercial building, we evaluated the rainwater quantities for residential buildings as well. So as you can see this table, we have considered the different housing types. So for this study, as I mentioned earlier, we used also historical rainfall data, and also we assumed different household appliances and what use scenarios. Uh, so we using the UWAT urban water optioneering tool to simulate the complete urban water cycle for this number of housing for 778 residential units. A quantified water balance is obtained. So this slide shows the result about water quantity. So if you look at the graph, except apartment units, all the housing units can collect enough rain for volume, uh, which can meet the non-potable water demand under the conditions we considered for this study. So from this study, we have learned how to analyze historical rainfall data for feasibility study of the rainwater harvesting system, and we have established some options for rainwater reuse and evaluated water savings and cost savings of the rainwater harvesting system. So these lessons will be valuable for further analysis on rainwater harvesting applications like rainwater harvesting for other commercial buildings like schools or hospitals and so on. And this is the next plan, and we will have some more result on water reuse using UWAS simulation software and energy and nutrient recovery. And last thing I want to mention that we have a plan to have our second COP meeting in January next year.